So this article is related to vector control of an induction machine using the PLECS RT box for real-time hardware in loop rapid control. Okay. So in this article, we have developed the complete real-time validation of a field-oriented control system induction motor drive system using the PLECS RT box, and the proposed system integrates a three-phase voltage source inverter, then induction machine and digital control architecture implemented in the synchronous rotating DQ reference framework. So the complete drive system is divided into two subsystems, which is plant and controller subsystems to enable the hardware in the loop and rapid control prototyping as well. The controller includes the DQ axis, proportional integral regulators, rotor flux estimation based on dynamic state space modeling, and coordinate the transformation using Clark, Clark and Park theory as well. So the system is validated under step torque variations, demonstrating the fast transient response, accurate torque tracking, and stable flux regulations as well. So next one is the introduction. In the introduction, I have added the complete details structure of the controller and plant in the hardware in loop setup used for real-time execution of the vector-controlled induction motor drive system implemented on the PLECS RT box platform. So the configuration consists of two RT box units where one is assigned to the plant subsystem and other is controller subsystem. In the VSI voltage source inverter, DC link supply and induction machine dynamics, it generates the analog feedback signals such as stator current, DC link voltage, rotor speed, position information, which are transmitted to the controller RT box as well. So the PWM switching signals based on the field orient control algorithm. These gating signals are then sent back to the plant RT box to the drive to drive the inverter switches in the real time. So with the advancement of power electronics, digital signal processing, real-time simulation platforms, we have used the RT box that has emerged an powerful toolbox. We can also use this MATLAB simulate model with no real-time constraint. However, the PLEX is one of the best satisfying strict timing constraint where each computation step must complete within the fixed sampling period. Okay. System architecture, these are the equations for the system architecture with the stable of the rotor flux dynamics, and then we have added the electromagnetic torque equations with its variables as well as the underfield orientation, then coordinate transformation and FOC theory, and then Clark Park transformation as well as the electrical angle computation as well. Yes. Splits frequency equations, then synchronization of speed as well as the controller design implemented in his it. Pi controller equations are used, which are normally equations. These are the normal equations in proportional, integral, reference currents, reference voltages, output. Then torque reference conversion equation, flux reference, as well as the complete equivalent circuit induction machine TQ framework, field oriented control system, then PLECS RT box implementation system, partitioning, and top level schematic of plant and controller system. And then we have added the real time constraint of the discrete implementation and the simulation output results for the controller drive system as well as the power circuit. This is a power circuit, and then this is a controller model of the induction machine drive system for the in the Plex. And this one is a power controller circuit for the DQ framework developed in the Plex. Structure of rotor flux estimator and the output results in terms of stator currents, rotational speed, and electrical torques are added in it, and then stator currents, direct currents, and the quadrature current are added in it. Okay, and then these are the rotor flux dynamics are added, then discussions and the conclusions with the references are added. So The vector control induction machine is basically this one. Start the simulation and then we explore the controller plant section in which would provide us the complete estimations as well as the plant pi controller with the power stage converter scopes are added in it. These are the static currents, direct currents, quadratic currents are added. Then we got the plant subsystem, which is basically also the DC input with the source inverter bridge circuits as well as the then the induction machine, squirrel gauge induction machine, then the output results in terms of rotor flux inductors. Okay, scopes are here in which stator grants rotational speed, electrical torques are added in it. Okay, so these are the complete system. So if you need to ask anything, you just ask me. I will answer your questions. Okay, thank you.